All right, still in section 4.1, we're going to talk about extreme values on a closed interval. Now, previously, when we talked about absolute max and mins, we talked about an absolute max or min on the entire domain of a function. Here, we're restricting it down so that instead of looking at the whole domain, we're just looking at one particular closed interval from A to B. And the extreme value theorem says if f is continuous on that interval A to B, then somewhere in that interval, f is going to attain an absolute maximum value and an absolute minimum in that interval. And this example here is shows like three different possibilities. Let's see, on this first one, the absolute max from between A and B, this is the highest point that it attains, and this is the lowest. On this next one, this is the highest point it attains, and it attains the lowest over here at an endpoint. And this third one, if you look at it, it attains its highest value here and here, and its lowest value is attained there. So the thing I want to point out here is it's possible that your absolute max or absolute min, you might attain it more than once. You could even attain it infinitely many times. But if your function is continuous and you're on a closed interval from A to B, you can go through there and find a largest and a lowest value. And here's a nice fact here. I don't know why the book didn't include this fact along with this part of the theorem, but the fact says the absolute max and min, they have to either occur at an endpoint or at a critical number. So let's do a few examples. Find the absolute max and min of this function on the interval from -2 to 1. All right, so let's take the derivative. We're going to get -1 minus 2x. And why am I taking the derivative? I've got to find the critical numbers. So let's see, if I take that and I set it equal to 0, then I get -2x is 1. So x is -1/2. So we know that the absolute max and absolute min have to occur, or they must occur at one of these two numbers or at 1/2. So what I'm going to do is come over here and just make myself a chart. X and f of x. So let's see, -2, -1/2, and +1. So now I'm going to plug these numbers into the function. Let's see, 7 minus -2. I should write this out. 7 minus -2 minus -2 squared. That's 7 plus 2 minus 4. Why am I doing this on my calculator? It's 5. All right, now the 1/2. 7 minus -1/2. So 7 plus 1/2. And then minus 1/2 squared, so -1/4. Gives me 29/4, or 7.25. And then if you plug in 1, you get 7 minus 1 minus 1 is 5. So the absolute max of this function is going to be 7.25. And the absolute min is going to be 5. Now, how do we write that? You could write it like this. But notice that that 5 occurred twice. So this is one way you could write your answer. You could also say that it has absolute max of 7.25 at x equals -1/2. and an absolute min of 5 at x equals -2 and x equals 1. That's probably how I would write my answer. You could also write them as points if you wanted to. But let's look at this. 7 minus x squared. All right, and just to make this easy, I'm going to call it f of x. And I'm going to put in these 3 points. I'm going to put in the points, let's see, our interval was -2 to 1. So I can put that in as -2 comma f of -2. Then f, or let's see, the next number was -0.5, -0.1/2, comma f of -1/2. Notice that one came from the critical point, so it's on the top. And then 1, f of, or let's see, 1 comma f of 1. See, those are our 3 points right there. And we can see that 2 of them are at the same height, and those give us the minimum on this interval. You know, if you wanted to, you could even come in up here and put in an interval. Let's see if I can remember how to do that. Let's see, -2 x. Yeah. And you get that less than or equal to by just typing less than and then equal to. So yeah, that's the interval we're looking at from -2 to 1. And so we get the absolute max. The absolute max occurring once, and the absolute min occurring twice. All right, let's do this next one. Find the absolute min, max and absolute min of this function on the interval from 0 to 32. This is an interesting function. We've got fifth root of x times 10 minus x. So first up, I'm going to rewrite this. F of x that's x to the 1/5 power times 10 minus x, which I'm going to rewrite that as, or I'm going to distribute that across and get 10x to the 1/5 minus x to the 6/5. And so my derivative is going to be, let's see, 1/5 times 10 is 2. 1/5 minus 1 is -4/5. This will be 6/5 x to the 1/5. Like this. All right. Now, to find the critical numbers, 0 is going to be one of the critical numbers. You can tell because plug in a 0 there, you get 0. But let's factor out what we can here. You can factor out an x to the -4/5. Why that? Well, keep in mind, if you were factoring out, say, x squared plus x to the 7th, you'd factor out x squared because that's the lower of the 2 numbers. Over here, the lower of these 2 numbers, these 2 exponents, is -4/5. So we'll factor that out. So we're left with a 2 here. Over here, we're left with 6/5, then x to the 1/5 minus -4/5. So I've got x to the -4/5 times 2 minus 6/5 x. Because we add those together, we get 1/5 plus 4/5 gives you 5/5. All right. This is going to give me 2 minus 6 over 5x over x to the 4/5. Now, true, I could factor out a 5 there and do some other stuff, and I could write that x in the bottom as the fifth root of x to the 4th, but I'm not going to. We're going to look at this and just say x equals 0 makes it undefined. And for the top, basically you set the top and bottom both equal to 0. The solutions that make the bottom 0 make the derivative undefined. And the top, 2 minus 6/5 x equals 0. That's going to give me 6/5 x equals 2, or x equals, let's see, multiply both sides by 5 over 6. So you get 10 over 6, or 5 over 3. All right, so those are my critical numbers right there. Now what's left is I have to make a chart. I'm going to put in x and then f of x. And the numbers that go here are, let's see, my critical numbers and my endpoints. Now notice 0 wound up being both one of the endpoints and a critical number, but we only need to include it once in the chart. All right, so once we plug in f of x, plug these numbers in, that's going to tell us the y value here. So if you plug 0 back into the original function, you get 0 times 10 is 0. If you plug in 5/3, you're going to get something ugly. I'm just going to do this on my calculator. Now, the way I'm going to do that is this. I'm going to put in 5/3 raised to the, let's see, 5/3 raised to the 1/5 power. All right, so 5/3 raised to the 1/5 times 10 minus 5/3. All right, so what I've got here is, my calculator looks like this. The part that you can't see is 5/3 raised to the 1 plus 5, or 1 divided by 5. Okay, when I hit enter, it gives me 9.2297. All right, and the 32, surprisingly, is an easy number to plug in. 32, when you plug that in, the fifth root of 32, is 2, and then 10 minus 32 is negative 22. So this is going to be negative 44. So this is my absolute max, and this is my absolute min. All right. Now let's look at this one on Desmos as well. I'm going to go ahead and let's see, main Desmos. Actually, let's get them both on screen at the same time. So let's see, to get this into Desmos, I got to type in y equals, now fifth root of x, the easiest way to do that is just to do x raised to the 1/5. Or you could put x to the 0.2 if you'd prefer. So this times 10 minus x. And sure enough, we've got a maximum here at The maximum occurs at 5/3, and the value is 9.23. The minimum, if we go from 0 to, well, let's zoom out. This function's kind of funny looking. It goes down pretty quickly on both sides, but we were interested in just between 0 and 22. So if you come over here to 22, the value is negative 22. Oh, wait, it's not 22, it's 32. At negative 32, or I'm sorry, at positive 32, our value is negative 44. Scroll that up so you can see it. Well, anyway, it's right there. So that's our max and min. And again, this one up here happens at 1 2/3, which is 5/3. All right, so that's the method for finding absolute max and min. You just on an interval, you just find the critical numbers, then you test the function at the critical numbers that lie in the interval, and you test it at the endpoints. The one thing to be careful about is sometimes you wind up getting critical numbers that don't lie in your interval. If you get those, just ignore them, because the question's only asking about that particular interval. All right, I want to talk more about the extreme value theorem, but I'm going to save that for the next video.